In today's lesson, we'll be learning how to solve problems using trigonometry, which means we're going to be combining all of the techniques that we've learned so far. If you recall, SOHCAHTOA is a mnemonic which is used to help us remember the three primary trigonometric ratios. SO stands for sine theta, which is equal to opposite over hypotenuse. That's where the S, O, and H come from. Ka stands for cos theta, which is equal to adjacent over hypotenuse, and that is where the C, A, and H come from. And TOA stands for tan theta, which is equal to opposite over adjacent. That is where the T, O, and A come from. It is important to remember that SOHCAHTOA can only be used for right triangles. A lot of students get confused with the terms hypotenuse, opposite, and adjacent. Remember, the hypotenuse is the longest side in a right triangle, and it is opposite to the 90-degree angle. So it would be right here. However, opposite and adjacent are both relative terms. They are relative to the angle which you are looking for or the angle that you are given. So let's say, for example, you are given this angle, which I'm going to call theta. That would mean this side would be called adjacent, and this side would be called opposite. And let's say, for example, you're given this angle, or that is the angle you're looking for. That would mean this would be the adjacent side, and this would be the opposite side. The sine law can be used to figure out the side lengths or angles of an acute triangle, which means a triangle that does not contain a 90-degree angle. The sine law is pretty versatile. However, you do need one important thing. You need a side length as well as the angle opposite to that side length. And with those two pieces of information, you can figure out side lengths and or other angles. The cosine law is used to figure out side lengths and or angles of an acute triangle, which means a triangle that does not contain a 90-degree angle. There are three different forms of the cosine law, but they mean the same thing pretty much. This is how I remember how to use the cosine law. Let's say, for example, you want to solve for side length A. That means you need three other pieces of information. You're going to need angle A, side length C, and side length B. Alternatively, if you want to solve for an angle, you need three pieces of information. You need all three side lengths, and you need to do a little bit of rearranging and isolating the angle which you're looking for. In our first example, we want to find x to the nearest tenth of a centimeter. Before we attack this problem, it is important to remember that there are many different ways of solving for x. So the way that you solve for x might be different from the way your friend solves for x, or it could be exactly the same. Anyways, before we begin, let's take a look at some of the information that has been given. So as you can see here, this is indicated to be a 90-degree angle. However, this is a 50-degree angle. Therefore, using some simple arithmetic, you can quickly figure out what the other angle is, and that angle happens to be 40 degrees. So that might become useful down the road. If we locate x, you'll notice that x is part of a triangle, which is an acute triangle. So a triangle that does not have a 90-degree angle within. That means you cannot use SOHCAHTOA for that triangle. However, you can use SOHCAHTOA for this other triangle, since that does contain a 90-degree angle. That means we can only use the sine law or the cosine law for the triangle which contains the side length of x. Because I know two of the angles within this triangle, I can easily figure out the third angle because the interior angles of a triangle adds up to 180 degrees. Therefore, angle A would be 80 degrees. How did I know that? Well, if you add up these three interior angles, it's going to be 180 degrees. Like I mentioned beforehand, we can either use the sine law or cosine law for this question. So let's go ahead and see if we can use the sine law. Now, some of you may would do this a lot quicker. However, I'm going to write out the entire sine law and substitute in values to see if we can actually use it or not. So I'm going to put A over sine of angle A is equal to C and the sine of angle C, which is equal to D and the sine of angle D. Let's substitute some of our known values. So side length A is 6.7, angle A is 80 degrees, side length C is the variable of x, that is what we're looking for, and angle C is 40 degrees, and side length of D is unknown, so I'm going to leave it as a variable, and angle D is 60 degrees. For sure, I'm going to be using this fraction since my unknown is in this fraction, and I'm going to be using a fraction which contains both the numerator and denominator. And that's a very easy choice, 6.7 over sine of 80 degrees. I'm going to rewrite these two fractions and I'm going to solve for x. It's really up to you how you want to do the next step. You can either cross multiply or you can just multiply both sides by the sine of 40 degrees. And that is what I'm going to be doing. Why am I multiplying both sides by the sine of 40 degrees? Well, I want to isolate x, and x is currently being divided by the sine of 40 degrees. Now, to get rid of it, you need to do the opposite operation to both sides of the equation. So that cancels out. And if you want to, you can throw that into your calculator. So 6.7 over sine of 80 degrees multiplied by the sine of 40 degrees. Now, if you're not careful, you might make a mistake entering this into your calculator. So I'm just going to rewrite it so it's a little bit more friendly. It would be 6.7 times the sine of 40 degrees divided by the sine of 80 degrees. That's going to be equal to x. Now, when you throw it into your calculator, you should get approximately 4.3 equals x, and I'm just going to make a therefore statement. Therefore, x is 4.3 centimeters. As you can see, this is a very quick and efficient way of solving for your side length of x. However, there is a different way that you can do this, which I'm going to show you in the next example. We're going to be doing the exact same example with a slightly different method. However, as mentioned before, we already can figure out some of these unknown angles. So I know that this is already 40 degrees, and I know by default that this is 80 degrees. In a previous example, I solved for side length x using the sine law. However, let's try solving for x using the cosine law. So using the cosine law, I'm going to be using the shortcut that I've mentioned before. I'm going to be using this arrow scheme. Therefore, if I'm looking for x, I'm going to be needing three pieces of information. I'm going to be needing angle C, I'm going to be needing side length D, and side length A. I already know angle C, I already know side length A. However, I do not know side length D. So I don't know what that is equal to, which means I'm going to have to figure that out using the numbers and angles in the right triangle. The right triangle being triangle ABC. So if I've been only given the angle of 50 degrees, that would make 4.5 centimeters the opposite side. And if I'm trying to figure out the hypotenuse, then I'm going to be using a trig ratio, which contains opposite and hypotenuse. And if you remember SOHCAHTOA, that would mean you're going to be using the sine ratio. So let's write that down. Sine theta is equal to opposite over hypotenuse. Okay, so let's substitute in those numbers. That is 50 degrees. The opposite side length, is 5.5 centimeters, and the hypotenuse is what I'm looking for. So I'm just going to leave it as hypotenuse. At this point, you can solve this in a few different ways. I'm going to be using a cross multiplication method. So that's going to give me the hypotenuse multiplied by the sine of 50 degrees, and that will give me 1 times 4.5. So if I'm trying to solve for the hypotenuse, I need to get rid of this multiply by sine of 50 degrees. The opposite would be divide by sine of 50 degrees. And I need to do that to both sides of the equation. Those are going to cancel out, and you can easily solve for the hypotenuse, which is 1 multiplied by 4.5 divided by the sine of 50 degrees. And if you throw that into your calculator, you're going to get 5.8743 approximately. Now, when you are continuing your calculations, you should carry a few extra decimal places to ensure accuracy, because if you start rounding too early, your final answer is going to be very, very off. Now that we have our hypotenuse, that means we have enough information to use our cosine law. And let's write our cosine law for our particular situation here. So I would have c squared is equal to d squared plus a squared minus 2dA multiplied by the cosine of angle C. So at this point, all you need to do is substitute in your known values. So that would be 5.87 squared plus 6.7 squared minus 2 multiplied by 5.87 multiplied by 6.7 and multiplied by the cosine of angle C, which would be the cosine of 40 degrees. Now, when you do these calculations, when you simplify these numbers, you have to be very careful that you are applying BEDMAS appropriately. Okay? So I'm going to first find the square of 5.87, which is roughly 34.51. And the square of 6.7 is approximately 44.89. Now I'm going to multiply all of these numbers together. So I'm going to multiply -2, 5.87, 6.7, and the cosine of 40 degrees together at once. And you're going to get approximately 60.30. So all I need to do is add and subtract these numbers, which is going to give me approximately 19.1. And since I'm trying to solve for C, I need to square root both sides to get rid of the exponent of 2, which just leaves me C, and you should get approximately 4.37. Now, the question asks us to round to the nearest tenth, so that would be 4.4 centimeters. So let's write a therefore statement. Therefore, C is 4.4 centimeters. This number is very similar to the number we figured out in the previous example. I just wanted to show you two different ways that two different students could solve the exact same problem. So one way is definitely more efficient and quicker, and the other way is a little bit slower. But you can see that in either case, you're getting the same answer.